Okay, so in this video, we're going to work on finding trig functions, evaluating trig functions for angles larger than 90 degrees or pi over 2 using reference angles and also using special angles. So if you haven't watched my video on special angles previous to this, you might want to go back and watch that first. All right, so we're going to start with this angle 3 pi over 4 and evaluate all 6 trig functions. You can, of course, convert this radian measure into degrees. We talked about how to do that on a previous video. But as I've said, most of the time in calculus, we'll be working in radians. So you do want to get comfortable working in radians. And if you're going to rely on changing your angle to degrees every single time, it's just going to take too much time and maybe even make life more complicated for you. But there's an easy way to think about these angles in terms of pi. So I've drawn my circle. We need to figure out where this angle puts us on our circle. So remember that facing the positive x-axis is an angle of 0. And the trick is I'm going to think of this angle 0 in terms of pi. I'm going to think of this as 0 pi over 4. I know that seems strange, but 0 pi over 4 is the same as 0. Now, if I rotate positively and I rotate all the way around half of a circle, we discussed that this angle is pi, half of a circle, but I'm going to think of pi in terms of fourths as well. So I can always think of pi as 4 pi over 4. So then the idea is if you start at 0 pi over 4 and you rotate around counterclockwise, and this takes you to 4 pi over 4, you must have passed 3 pi over 4. So how would I get to 3 pi over 4 from 4 pi over 4? I would go backwards by pi over 4. So I'm going to go back minus pi over 4. And remember, pi over 4 is 45 degrees. So that's going to put us right here. So this angle right here is 3 pi over 4. I can label it from there. I can label it up here. And here's how it works with angles larger than 90 degrees. I'm going to make a triangle out of this, and I'm going to make my triangle based from where I ended up here. I'm going to go straight down to the x-axis and make my right triangle right here. And what's important to see is this angle right here, the part we went back by from 4 pi over 4 to 3 pi over 4 is pi over 4, and that is my reference angle. Oftentimes we denote reference angles with like alpha, whereas the angle itself we usually call theta, but that's just notation. So then the idea is we're going to work with this triangle, and we've seen this triangle before. This was one of our special angles, so I'm going to reconstruct it here, but again, you might want to go back and look at the previous video on special angles to get a better idea of this. We saw on a previous video that for a pi over 4 triangle, the sides can be thought of as 1, 1, and root 2. And so what I can do is I can label these sides in the same way. This triangle's flipped over, of course. This side is 1, this side is 1, and the hypotenuse is root 2. Now, the one difference is since we're plotting this angle on the xy plane, and this is moving in the x direction, one's moving in the y direction, this is a negative x direction. So we're actually going to make this negative 1 because we're moving to the left. This is going up positive 1 in the y direction. And root 2 is like the radius of the circle, which is always positive. So we don't have to worry about the sign there. And so the deal is then to find the sine, cosine, tangent of 3 pi over 4, we actually just work with this triangle with the reference angle. So using our definitions, the cosine, I don't know why I'm starting with cosine this time, that's okay. Cosine of 3 pi over 4, cosine, recall, is adjacent over hypotenuse from the reference angle. This would be the adjacent side, this is the hypotenuse, and this is the opposite side. And again, just to emphasize this, this is what I'm calling a reference angle. It means even though 3 pi over 4 is the angle we're finding the cosine of, we're going to refer to the reference angle, this triangle, and using the sides of that, that's going to tell us the sine, cosine, and tangent. So cosine of 3 pi over 4 is adjacent over hypotenuse, -1 over root 2. We talked about that that's the same if you multiply top and bottom by root 2 over root 2, that's the same as negative root 2 over 2. Either one is fine. The sine of 3 pi over 4, sine is opposite over hypotenuse, so that would be 1 over root 2, multiply top and bottom by root 2 over root 2 is the same as root 2 over 2. And the tangent is opposite over adjacent, so I get 1 over -1, which is just -1. So this problem asks for all 6, so once I have these 3, as long as you know which trig function is whose reciprocal, then we can get those very simply. So the reciprocal of cosine is secant. Cosine of 3 pi over 4, I'm going to use this value, is -1 over root 2. That means the secant of 3 pi over 4 is negative root 2 over 1. Just take the reciprocal of that, which of course is just negative root 2. The cosecant of 3 pi over 4, that's the reciprocal of sine. So if sine of 3 pi over 4 is 1 over root 2, cosecant is root 2 over 1, or just root 2. And the cotangent of 3 pi over 4, the reciprocal of 1 over -1 is -1 over +1, and that's still -1. So we have all 6 trig functions. All right, so let's practice more. Next one we're going to do is for the angle, slide that up, 7 pi over 6. So we'll start with figuring out where this puts us. Now this time, if I want to know where 7 pi over 6 is without converting to degrees, I'm going to start at 0 and I'm going to think in sixths. So 0 is the same as 0 pi over 6. I'm going to rotate positively. This puts us at 6 pi over 6. And you can see we're not quite there, right? If I want to get to 7 pi over 6 and I rotate half a circle to take me to 6 pi over 6, I just have to go 1 more pi over 6 further. In other words, just from here to here, I'm just going to go pi over 6 in the positive direction. Make my triangle, always go back to the x-axis. This reference angle now is how much it took to get from 6 pi over 6 to 7 pi over 6, which is just pi over 6. So my alpha is pi over 6. And we're in quadrant 3. So this was another special triangle. So again, back from the previous video, I think I had it written this way, but I'll just reconstruct it. This way, meaning I think the way we did it, we had this is pi over 3 and this is pi over 6. Those two go together. And if you recall, this is 1, this is 2, and the way I remember is the one opposite the pi over 3 is my root 3. So I can then label my triangle here on my circle. The one opposite the pi over 6 was 1. This side was root 3, and this side was 2. But like the last problem, for the movement in the x direction, this is going to the left pi over 3, so I have to make that root 3. And this is going down, so I have to actually make that -1. Hypotenuse is always positive. So from pi over 6, this would be the adjacent side. This is the opposite side. And 2 is the hypotenuse. For this one, why don't we just do the big 3, meaning sine, cosine, and tangent. So if I want to do the sine of 7 pi over 6, I'm just going to use my reference angle. Sine is opposite over hypotenuse, -1 over 2. Cosine, adjacent over hypotenuse, -root 3 over 2. And tangent, opposite over adjacent, (-1 over (-√3), which actually makes this +1 over √3. Totally fine to leave it like that. If you decide to, you could rationalize this by multiplying top and bottom by √3 and think of 1 over √3 is the same as √3 over 3. Either one is fine, this or this. So you can see that what it really matters is you have to find out what quadrant we're in, so that way we can get the signs correct in terms of the negatives. And then we need to know what the reference angle is. And then it's just a matter of replacing this triangle with the correct side lengths and just using your definitions of sine and cosine. Let's do one more. If you think you've got this, you might want to pause the video and try to practice figuring out what quadrant 5π/3 puts you in and what your reference angle is. Okay, so we'll do this together. So now I want to think in thirds. So I'm going to start at 0, which I can think of as 0π/3. Go all the way around to here. Notice I never stop at the y-axis. I'm always doing half a circle at a time. And this is pi, also known as 3π/3. Now this one's a little bit tricky. We're not quite there yet, right? If I go from here to here, that's 3π/3. So to get to 5π/3, I can either from 3π/3 go forward by 2π/3, or let's consider if I just kept going around here, one trip around the circle we know is 2π, and I can think of 2π as 6π/3. From 6π/3 to get to 5π/3, all I'd have to do is go backwards by 1π/3. The reference angle is the closest angle back to the x-axis. So even though from here I could go 2π/3, it would be faster and smaller if I work from 6π/3 and just go backwards by π/3. So my triangle would be in the fourth quadrant. My reference angle would be, even though we went back by π/3, you don't need to make it -π/3. You can just use π/3. And using the triangle we saw there, the side opposite π/3 is the √3. It is going down, so it's negative. This side is 1, that's in the positive x direction, so that's going to be positive. And this is 2. So we could do sine from here, opposite over hypotenuse, cosine of 5π/3, adjacent over hypotenuse, 1/2, tangent, opposite over adjacent, -√3 over 1 is just -√3. And let me just write that down since I said it, but just to be clear, the reference angle is the closest or smallest angle back to the x-axis. Again, that's why we didn't go from 3π/3 to get to 5π/3, which is right here. We didn't go 2π/3 because that's actually bigger than 90 degrees. We want it to be less than 90 degrees. That's the other thing. We want it to be less than π/2. Okay, so we'll practice more of this, but let's just pause for a second because there's a nice observation we can learn from these last 3 examples. If we think about in each quadrant, let's talk about the big 3, which trig functions are positive of the big 3. I'm going to put of, sine, cosine, or tangent. If we had a triangle and remember the quadrants, this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. If we had a triangle in the first quadrant, you can hopefully see that all of your trig functions would be positive because you're going to be using a positive x value, a positive y value to make your triangle. So in the first quadrant, all of your trig functions are positive. And so what we can do is just denote that with an A. That means all. In the second quadrant, if you go back to the first example we did, we had 3 pi over 4. That would put us in the second quadrant. And of the big three trig functions, cosine, sine, tangent, the only one that was positive was the sine. And you can hopefully see why, because from your triangle, you're going to be taking opposite. This is positive going up over the hypotenuse, which is always positive. And so the other two, because they involve the adjacent side, are going to come out to be negative. So any triangle that puts you in the second quadrant, only the sign would be positive. So what we can do is just put an S for that here. I'll just write it below, but mainly just the S is what we use for this acronym. Now, of course, if sine is positive, then so is its reciprocal. So cosecant would also be positive, but we kind of just know that would always be true. So we really just work this out with sine, cosine, and tangent. In the third quadrant, that was my second example. And in the third quadrant of the big three, the only one who came out to be positive was tangent this time, because the opposite and adjacent were both negative. So the negatives turn that into a positive. Third quadrant, then tangent. And then finally, the one we just did in the fourth quadrant, only cosine was positive. The other two were negative. So we can put cosine here. And so it's helpful to know, we'll see in future problems, in each quadrant, which of the big three trig functions are going to be positive and which ones should then therefore be negative. And so this acronym we have, many of you may have heard this before, but one way to remember this is all students take calculus. So if you think of the first letters, starting from quadrant one, going counterclockwise, ASTC, all students take calculus, all sine, tangent, cosine. Okay. So it's a good thing to know, and we will be using that going forward. Okay. So the next example, 39 pi over 4 is a very, very large angle. And this example shows you why you probably don't want to convert to degrees, because if you did, this is going to be a huge degree, probably in the thousands, if you convert it to degrees. But if you stick with radians, it's really not that bad to find the sine, cosine, and tangent. So let's try it. Now, 39 pi over 4, like we did the previous three, I want to think in pi over 4s. So I could start with 0 pi over 4 at the origin, go around here. This is 4 pi over 4. We've got a long ways to go. If you kept going around here, one trip around the circle is 2 pi, which in fourths is 8 pi over 4. Still got a long ways to go, right? So we can just keep going around the circle. In other words, if I did another half of a circle, that would be another 4 pi over 4. Added to 8 pi over 4, this would be the same as 12 pi over 4. But I still got a long ways to go. So maybe a faster way to do this is to realize that, of course, this is 0, this is 2 pi. If we don't think in fourths, one more trip around the circle would be 4 pi, 6 pi, and so forth. Every time you go around the circle once, twice, 3 times, every time you end up here, notice it's always an even number times pi. And over here, if we reduce those, pi, 3 pi, the next one would be 5 pi. All of your odd pi's put you on this part, on this side of the circle. Okay, so let's keep that in mind, because here's maybe a more efficient way of trying to figure out where it puts us rather than just keep going around the circle and counting by fourths. Notice that 39 pi over 4 happens to be 40 pi over 4 minus pi over 4. And 40 pi over 4 is 10 pi. And based on what we're seeing here, we know that 10 pi would be, well, actually 5 trips around the circle, but 10 pi would put us exactly right here, right? If I just added 2 more here, 8 pi, 10 pi, right? 5 trips around the circle. So what this tells us is 39 pi over 4, the one way I can think of it is I go around the circle 5 times, end up at 10 pi, and then I subtract pi over 4, meaning I go backwards by pi over 4. I can now tell that 39 pi over 4, after going around a bunch of times, will put me right here on the circle, 39 pi over 4. More importantly, I know that my reference angle is going to be pi over 4, which is a special angle, and I know the sides on that one, 1, 1, root 2. Okay, getting back to this all students take calculus idea, a very common mistake you can probably imagine in evaluating these trig functions is to forget to address, should one or both of these be negative, right? And of course, the 1 is going down here, so that should actually be negative. It's a negative y direction. But one way you can catch yourself is if you think about all students take calculus, then I'm just going to put sine of theta, cosine of theta, tangent of theta. We know that in the 4th quadrant, only cosine should be positive and the other 2 should come out to be negative. So that's kind of a nice way to check yourself and make sure that you're getting the correct sign. Okay. All right, so sine would be opposite over hypotenuse, -1 over root 2. I'm just going to leave it like that. Cosine is adjacent over hypotenuse. And tangent, opposite over adjacent, -1 over +1 is -1. Okay. It's probably another good time. If you want to practice on your own, you should pause the video and see if you can figure out, hopefully without just going around the circle a bunch of times, an efficient way to figure out what quadrant 31 pi over 6 is and what your reference angle is. Okay, so a quick way to get to 31 pi over 6 is to think of 31 pi over 6 happens to be, you want to think of a number that 6 divides in evenly that's close to 31 pi. Hopefully you thought of 30 pi over 6, but in order to get to 31, you would have to add pi over 6. 30 pi over 6 is 5 pi, and 5 pi would be a few trips around the circle winding up right here. 5 pi, all your odd pi's will put you right here. Now it says from there I want to add pi over 6, so I'm going to go further by pi over 6. Here's 31 pi over 6. My reference angle is pi over 6, and we know the sides from that. This would be 1, although it's going down, so it should be -1, root 3, and 2. That's just using the special of a triangle again. Sine, cosine, tangent. If you remember to put that negative, it should take care of itself, but you could also think about all students take calculus and realize that tangent should be positive. The other 2 should be negative. Sure enough, sine is opposite over hypotenuse, -1/2. Cosine is adjacent over hypotenuse. So I forgot to put the negative there. -root 3 over 2. And I caught myself because I knew it was supposed to be negative. And tangent is opposite over adjacent. Of course, it is negative over negative, but those 2 negatives are going to cancel. So that's going to end up being +1 over root 3. Okay, one last example here. And just to remind you, the ones I've done so far involve special angles. An angle like 15 pi over 2, which is many trips around the circle. In fact, there's a couple of ways we could think about how to get to 15 pi over 2. You could either think of it as, why did I put 6 there? That should be over 2. You could either think of it as 14 pi over 2 plus pi over 2, or 16 pi over 2 minus pi over 2. If you think of it as 14 pi over 2 plus pi, I keep wanting to put 6. I'm so sorry. That is the same as 7 pi plus pi over 2. If you think of it this way, that's the same as 8 pi minus pi over 2. But now let's think about this. 7 pi would put us right here. And adding pi over 2, what you have to understand is pi over 2, is a quarter of a circle. That's a right angle. So if I add pi over 2 to that, that's going to put me right here. If I thought of it as 8 pi, which is an even pi, which puts me right here, and then go backwards by pi over 2, it puts me in the same spot. So you can think of it either way, just have to know that it's going to take you right here. And because it puts you on one of the axes, it's not going to be a triangle problem. This goes back to, for now, as on a previous video, we talked about if the angle puts you on one of the axes, then you want to think about the unit circle for now. And you want to think about which, on a circle with a radius of 1, what would the coordinates of this point be? It would be 0, -1. And we saw that on a unit circle, if this is x and this is y, the sine of theta is literally the y value, so it would end up being -1. The cosine of theta is literally the x value, so that would be 0. And the tangent of theta, you can either think of it as sine over cosine or y over x. I'm going to do sine over cosine. -1 over 0 is undefined. All right, so this is really critical to practice evaluating sine, cosine, tangent, any of the trig functions for these types of angles. So lots and lots of practice. You need to get good at this. You'd be expected to do these without a calculator in most cases when you get to calculus.